All right, so now we're going to be stepping into something a little bit different, or at least maybe a little bit more specific, and we're going to take a look at right angled triangles. Okay, very specifically, we're going to take a look at right angled triangles. And a right angled triangle, okay, is any triangle where one corner, okay, so one of our angles that we've talked about has a measure, okay, or an angle of 90 degrees. So one of our corners is going to have an angle of 90 degrees. This means that the other two angles, and again, based on what we know about our triangles, okay, a triangle has a total of 180 degrees. So if one angle is 90 degrees, now that is it's a square angle or right angle. It'd be like a T, okay, perpendicular. This means that the other two angles will add up. Okay, so 90 degrees has already been taken up. The other two angles have to add up to the other 90 degrees. Okay, so one angle is 90 degrees, the other two combined are going to be 90 degrees as well. So that's a right angle triangle. Now, we're not going to worry too much about angles right now. We'll take a look at that in subsequent lessons or coming up lessons. But today we want to take a look at just our sides. And this is in our little bit of review. So we're going to take a look at Pythagorean theorem. Okay, you've all done Pythagorean theorem last year, or at least you should have done Pythagorean theorem last year. And so it deals with, again, a three-sided triangle where you know two sides and the one side you don't know. Okay, so trying to find the third side of a triangle. The first thing we're going to do when we talk about Pythagorean theorem is we need to label the triangle where A and B. Now again, this is going to be slightly different than what we've done in the past, but we could put it all together that way as well. A and B are the two legs of the triangle. When we talk about legs, we're talking about the two pieces that are attached to the right angle. Okay? So in this triangle right here, the right angle is this little square here in the corner. So that means that our two sides, 13 and 29, are going to be our A and B. Now again, order does not matter. Okay, order is completely voluntary on your part. You can say that A is the top one and B is the bottom, or vice versa. It doesn't matter when it comes to doing calculations. The final side is important and it does matter, and that is C. Okay, so C is our third side. Okay, you've heard this before, and we've actually talked about it in class, Pythagorean theorem. Okay, when we're labeling, C is always going to be the longest side, which in that case is also going to be the one not touching the right angle. Okay, we have another name for that, and we call that the hypotenuse. We're going to talk hypotenuse a little bit later on when we get into finding more sides and angles, more specifically when we deal with both of them and our trig ratios. But right now we're just going to use it, we're going to call it C. Now in this case right here, let's say that we want to try to find the missing side. Okay, so this missing side right here is our longest side. So we would then want to find C, okay, our hypotenuse. It's our longest side. To do that, we use our regular Pythagorean theorem. Okay, the one that you've seen in class before, prior to this, the one that you've seen in class here, and that is a squared plus b squared is equal to c squared. That is Pythagorean theorem. And I apologize that line isn't quite long enough. I did not make it long enough in there. Okay, so that is to find our missing side. And a squared plus b squared is equal to c squared. Okay, you've seen this before. So you take this side here and you square it. You take this side and you square it. You add those two values together, and that's good. And then you take the square root of the answer to come up with c squared. And we'll do a couple of examples of that right away. The other way, and this is if also one of the legs are we need to find one of the legs. So in this case here, you'll notice the second triangle. We're given the long side. We're given the hypotenuse is 13, and we know that one of the legs is 5. We want to find the other one. We need to mix around our formula a little bit. And so what we're going to do is, if we want to, let's say, try to find b squared, it is equal to c squared minus a squared. Okay, so if you want to find b squared, or b, then you use this formula right here. Now, at the same time, if what we said before is that a and b can be switched. Okay, so a and b can completely be switched, and so we could actually write this as a squared is equal to c squared minus b squared. Okay, we could write it like that as well. It's the same thing because a and b are completely switchable. Okay, in the equation, we could also switch to the top one here. We can do b squared plus a squared, be exactly the same thing. It does not matter. Okay, it does not matter. Just make sure that when you're doing it, we understand that we are subtracting here. In this case here, we are, and on the top one, we are adding. Let's do a couple of examples here. The first one is you want to find the missing side. We have 13 and we have 29. We want to find out what this side is here. So when you're doing a question like this, and this is going to be the case in all trig questions, some of the label will be a little bit different, but in this case here, we need to make sure that we label it with A, B, and C. And so what I'm going to do is I'm going to label this with A, and this one I'm going to label with B. Okay, they're the two legs. Again, we could do this B and this A, and that one works as well. But the longest side here, the hypotenuse, is always going to be labeled C. Okay, so we're going to be trying to find what is C. So I don't need to go quite that far down. All right, so we want to try to find C, so that means that we're going to be using this top equation right here. A squared plus B squared is equal to C squared. And I might actually be able to do it on the side to make sure that we have enough room here. So we're going to do our formula bar here. A squared plus B squared is equal to C squared. So we have our equation there. Now we're going to put our values in. So we insert our values into the equation. Now A is 13, so it's going to be 13 squared plus 29 squared, which is B, and that's going to still equal to C squared. Okay, so we're still just looking for C squared. Now, here's one thing that I've really noticed in when doing these questions where some students make an error is now they add the 13 and 29 together. And so then C all of a sudden is 42. That's not what we're doing. Remember, with order of operations, we need to square our numbers first. So 13 squared, okay, is 169. I want to have memorized. 29 squared, I don't. So I'm going to take a look at the calculator here. 29 squared is 29 times 29. At 29 times 29, so that's 841. We're going to put that in here, 841. 41. And that equals C squared. Now I'm kind of encroaching a little bit on that other one, so I'm just going to slide this over a little bit. There we go. All right, now I have I figured out what the square part is of it. Okay, and I'm going to show you how I'm good with you doing this in a little bit later on when it comes to how to show your work. You don't need to show all this work, but I'm showing you what we actually do. So now we add together 169 and 841. And 169 plus 841 would be 1010. Let me just double check here. 841 plus 169, 1010. Good. I think that's what I put down there. Okay, is equal to C squared. Now at this point here, we want to try to figure out what C is, not C squared. If this is 13, this is 29, this is definitely not 1010. Okay, that's for sure not the right case. So we need to we want to find just C, not C squared. To do this, and again, we've done this over time in both in this class, and you've probably done this in grade 9 as well. We need to take the square root of both sides to get C all by itself. Okay, so we need to take the square root of both sides to get C all by itself. And what that's going to be, we take the square root of 1010 on the calculator here. Square root 1010 is 31.78. 31.78 is equal to C. So that means that this side right here is 31.78. Now again, C is always going to be the longest side. It's always going to be the longest side. So it should be longer than these two sides. Not much longer, but definitely longer. Okay, depending on the triangle, it could be a little bit longer, it could be just a very tiny little bit longer, it might be a slightly bigger bit longer than the longest side, but that's important that we understand how to come up with that. So this would be our side, 31.78. Now I showed it in great detail here. Okay, I showed you in great detail. What I want you to do is I want you to show me what numbers you're putting in. Okay, that's the first thing. Then you should come up with either your answer or this part. You don't need to show this second part, okay, but you might want to show your answer to when you add them together and then show your square root, because the square root is important as that is the side. So look at the second question here. I'm going to do it with a different color because I know I kind of squeezed some things in there. I'm going to label in deep purple. Longest side right here is C. Okay, now I have two missing sides, okay, and the labeling that I do doesn't matter. I'll be honest, if you look back at my notes on the same question from different years, I probably switched around the A and the B on numerous occasions. See if we can get a B in there. There we go. So we have A, B, and C, and we're trying to find A. Now, if we're trying to find A, what that means is that we need to use this bottom equation here. Okay, think of it as the bottom equation. Again, they're all just fine. We can gladly use either one of those. Okay, A's and B's mixes up, but we're trying to find A, so we're going to do A squared is equal to C squared. Now, C is always going to come first, minus B squared. Now again, when we do this on our calculators, or sorry, when we plug in our values, the A squared we don't know because that is our blank side. Oops, not subtract, equals. Now C squared will be 13 squared minus, okay, B is 5, so it's going to be 5 squared. Now if you're doing this on your calculators, you can just punch in 13 squared minus 5 squared. Okay, and that will give you the answer that we come up with, and I'll go through that, but I'm going to do one step more here. I'm actually going to do what 13 squared is. A squared is equal to 13 squared, which is 169, minus 5 squared, which is 25. And when we actually do the subtraction, A squared is equal to 144. I've done this a couple times. I understand the numbers. I've done that. I've done that a lot. Now on your calculators, what I want to see you do, and that's going to be right up here. Okay, 13 squared. I did a space bar and I shouldn't have. There we go. Okay, minus 5 squared. Okay, equals. That gives us 144. Okay, that's exactly what we did here. That's what you need to punch in. Okay, show me that. You don't need to show me this third step here. Show me this step and this step at the bottom here. Because once we get here, now we need to take the square root. Okay, so now we take the square root because we need to get A all by itself. This side is not 144. It's a square root of 144. And so we need to now show that. So if we take the square root of A squared, it's going to be just A. And if you take the square root of 144 on your calculators, you can do that. You should get 12. Okay, this is going to have a side length of 12. Now this is what we would call a Pythagorean triple. Okay, the numbers, there's no decimals in there, which is really nice. It doesn't happen all the time. Here we had decimals, round to 2 decimal places, use that value as an answer. But we can also get to a 12 there as well. So that is the conclusion of Pythagorean theorem. I have a little bit more on labeling triangles coming up, but I'm not going to deal with that now. I'm going to actually put those videos in with the next lesson. As they go a little bit better with that, maybe I'll need to organize that a bit better for next year. So you guys will just have to kind of touch back there. But your assignment is TR.01, numbers 1 to 10. It's going to be on the next page. It's numbers 1 through 10. On the assignment. If there's no diagram, please or make sure that you draw a diagram for your weekly progress check. You'll have to draw a diagram and make sure you label it. Make sure you show what you're doing. Okay, and then solve. And most of those questions are going to deal with Pythagorean theorem.